All right, today we are going to be talking about friction. I think we all have a pretty intuitive idea of friction, but maybe you'll learn something new here. So friction is a force that opposes motion, okay? And the direction of a frictional force on an object is tangent to the surface where the friction acts, okay? Now, the way we measure kind of the strength of friction or how strong a frictional force could be is with a coefficient of friction. And we actually have two coefficient of frictions. We have mu sub s, which is the coefficient of static friction, and mu sub k, which is the coefficient of kinetic friction. All right, and I'll talk more about that in a second here. Now, I think intuitively we know that how much friction there is or could be depends on the two materials that are in contact with each other. For instance, if you are ice skating, you have like a metal blade on ice, you can slide pretty easily. There's very low friction. Compare that to if you have a rubber shoe, like bottom, on dry concrete, you're not going to slide that easily. There's a lot of friction there. The coefficient of friction between rubber and concrete when it's dry is a lot higher than the coefficient of frictions for like metal on ice. You can see that like with the table here, if you have a block of ice, you have like a coefficient of friction of 0.1 for the static coefficient, 0.03 for the kinetic coefficient. Compare that to, rubber on concrete there. The static coefficient is 1, kinetic is 0.8. So if you know the two materials, you can look up their coefficient of frictions. Okay, now static friction is when there is no relative motion between two objects. Now, kinetic friction is the opposite, right? There is relative motion between the two objects that are, exerting friction on each other. Now, you'll notice up here that the static coefficient is always higher than the kinetic coefficient. And to understand why, we need to talk about what kind of causes friction, or one of the ways friction can be caused. So if we have a box here, let's say weight 10 newtons, and we apply a force here to the right. If this box is not moving at first, this box wants to start moving to the right clearly, because we apply a force to the right. So we can do some of the forces in the x direction. We just get this. So it wants to move to the right. Friction doesn't like that. Friction opposes motion. So what happens is there's a frictional force on the box to the left. Okay, friction opposes motion, or the tendency for an object to move, right? So it doesn't mean the box is moving, but it kind of wants to move to the right. So friction opposes that, applies a force to the left to keep it from moving. If we zoom in at this bottom surface of the box, it might look something like that. The box is not perfectly flat. There's microscopic little ridges, right? If you keep zooming in, and the ground has microscopic ridges too. And so these ridges can bump into each other. Right? They can contact each other. And so those ridges will exert forces on each other. And those forces, they oppose those ridges trying to push past each other. Right? They oppose motion. And those little ridges bumping into each other is part of what causes friction. There's other things like molecular attraction and stuff too, but this is just one of the mechanisms behind friction. Now if I highly exaggerate here, so if this is the box, the ground has some ridges like that. If the box is not moving, these ridges will overlap quite a bit. Okay. However, if the box starts moving, so there's relative motion between the box and the ground, those ridges will still overlap, just not as much as if there was no relative motion. So the ridges, how much they overlap is a lot less. And so you get less kind of bumping into each other, so you get less friction. Hence, the coefficient of kinetic friction is always lower than the coefficient of static friction. Now, what does this all really mean? What is a coefficient of friction? Going back to our box example, this box has a weight of 10 newtons, and it is not moving relative to the ground. I apply a force of 1 newton. Let's say between those two objects, the coefficient of static friction is 0.3. Coefficient of kinetic friction is 0.2. Okay, what you do is draw a free body diagram, just like pretty much every problem in statics. Free body diagram, a force of the weight of 10 newtons down, it rests on this, like the ground. So the ground can exert a force upwards, normal to the surface. I call that N. It's normal to the surface because that force is normal perpendicular to the surface where the force acts, right? We have our 1 newton to the right. If I do some of the forces in the x direction, it's not going to be 0. It can't be 0. Okay. The sum of the forces is to the right, to rightwards with 1 newton. Notice I didn't include friction yet, right? The first step of a friction problem is assume that there is no friction. Draw the free body diagram and find the direction the object wants to move. So this object is not moving right now, but there's a net force to the right. There's nothing to oppose that, so the box wants to move to the right. So friction opposes that, so it is going to be a force to the left. Right? Without friction, the box wants to move to the right. We just found that. You can just see it by doing some of the forces in the x. Friction doesn't like that, so it applies a force to the left to oppose that. Okay, I'm going to call this F. In order for this box to be static, it's pretty clear that F must equal 1. So the frictional force must be equal to 1. But there is a maximum amount of friction that can be exerted. The maximum amount of static friction that can be exerted is N times mu s. N is the normal force acting on the object, the force normal to the object surface. So from some of the forces in the y direction, N is 10 clearly. Coefficient of static friction is 0.2. So the maximum amount of static friction is 2. Maximum. Okay, it doesn't mean there is 2 newtons of friction. It just means there could be. In order for this object to be static, we found that the friction needed to be 1. This object is not moving, so it's static friction. And so, 1 is less than 2. The amount of friction required to keep it static is less than the maximum amount of static friction that there could be. So everything's fine. What if this was 2? Well, in order for it to be static and not move, the frictional force needs to be 2. Okay, the frictional force is just equal to the maximum amount of static friction, so everything's fine. Okay, the object is very close to moving. In fact, if you apply just a little more force here, the object is going to start moving. It's going to start accelerating. What if that was 3? Right, well, in order for the object to be static, that frictional force needs to be equal to 3, but the maximum amount of static friction is 2, so that can't happen, right? You cannot have 3 newtons of friction here. So the object is going to start accelerating because it started off stationary. It's going to start having a velocity. Okay, so it's going to start moving relative to the ground now. And so, remember, kinetic friction is when there is relative motion. So if I apply 3 newtons of force, in order for it to be static, there needs to be 3 newtons of friction, but that can't happen because the maximum amount of static friction is 2. So the object is going to start moving. If it starts moving, now all of a sudden there's relative motion between the box and the ground. So now all of a sudden we transition to kinetic friction. Now the amount of kinetic friction is N times mu K. Okay, doing this, the amount of kinetic friction is 3. Okay, so if this object was not moving, in order for it to have no relative motion, if the object started off not moving, in order to keep it like that, you need to have a frictional force of 3. But the maximum amount of static friction, again, static friction is when there's no relative motion, is 2. So then the object is going to start accelerating. And it's going to start moving. But once it starts moving, we all of a sudden transition to kinetic friction. How much kinetic friction is there? 3 newtons. Right? Static friction here, this was the maximum amount of static friction. We're now working with kinetic friction now. That is how much kinetic friction there is. Not how much there could be, how much there is. All right, so let's say this was 4 newtons. If the box started off not moving relative to the ground, because there's no relative motion, we are working with static friction. How much static friction does there need to be? 4 newtons to make sum of the forces in the x equal to 0. But there can't be 4 newtons of static friction. There can only be at most 2. So the object is going to start moving. It starts moving, so we know we need to look at kinetic friction now. How much kinetic friction is there, right? 3. So there is 3 newtons of kinetic friction. So the sum of the forces in the x direction of this is not 0. It cannot be 0 in this problem, the coefficient of frictions just aren't high enough. So the object is going to accelerate. It's not going to be static. Okay, so the first step is assume that there is no friction. Find the direction an object wants to move. Again, this is all if the object is not moving at first. Find the direction it wants to start moving. And then friction opposes that. So you now know the direction of friction. Draw that in the free body diagram. Again, if the object is not moving, find how much static friction there needs to be to keep it static. Compare that to the maximum amount of static friction there could be. If the friction needed, like if this was 1, so you need 1 Newton of friction to keep it static. The friction needed to keep it static is less than or equal to the maximum amount of static friction, then everything's all good. Okay. If the amount of static friction needed is greater than a maximum amount of static friction that there could be, then the object is going to start moving. And if it starts moving, now you look at kinetic friction, calculate the amount of kinetic friction, so 3 newtons here, and that is how much kinetic friction there is. And then later you can look at, is the object going to be static or not? In this case, we have 5 newtons to the right, 3 newtons of kinetic friction to the left, and so it's not going to be static. It's going to accelerate. Okay, so this is kind of how you work with friction, the coefficient of frictions. We'll do a few examples in future videos, but yeah.